All right, 3.2. We're going to put some structure to the logic that we started working with in 3.1. The structure that we're going to put to our logic is something called truth tables. And we're going to talk about when we can know or how we can find out if statements are equivalent using them. Okay? So one of the things that we talked about in 3.1 is we talked about different kinds of connectives. In particular, in this section, we're going to be looking at the connectives that are and or, and we're going to see some negations pop up as well. Okay, so if then, that conditional connective, that's in section 3.3. So we'll get to that in the next section. So for starters, we're going to look at a conjunction. Conjunctions are and statements. So it's that upside down V, or it looks like part of a letter, capital A. A conjunction is true when both statements are true. And we're going to use an example to help us create the truth table. So my example is going to use these statements for P and Q. P is going to be the statement, I'm a woman, and Q is going to be the statement, I teach math. Everybody good so far?
Is this under the truth table?
Yes, it's going to be in the truth table part. You can put it to the side of it, or this, you've got lots of space, so you'll have space there. So what we're going to do is we're going, oops, that was a little too thick. One more time, just a sec. That'll work. Is we're going to draw a table that's going to look kind of like an XY chart, you know, back in algebra when you did like X values and Y values. And it's going to have a third column over here, so it's going to have 3 pieces. The first column we're going to label with our first statement, which we call P. That's very common. You'll see P's and Q's used a lot. They don't have to be P's and Q's, but those are sort of the go-to ones. It's kind of like in algebra. If you talk about algebra, you're probably thinking X and Y, right? Not you have to. It's just what we typically use. So the second column is going to be Q. And the third column is going to be P and Q. Okay, everybody good so far? All right. One option is that both statements are true. So this would be me. I would be walking in, and I would be saying, I am a woman, and I teach math. And not a single one of you would blink your eye and say, that sounded weird. Why'd she say that? Right? Because both those statements are true, so joining them with the word and makes sense. It's a true statement. All right. Do you guys know, let me pick someone for you. We'll go with Dr. Rohr. Do you guys know Dr. Rohr? Okay, got a lot of nods. Dr. Rohr is one of our English professors, and Dr. Rohr is Jessica Rohr. She's a female, okay? So Dr. Rohr walks in, and she says, I'm a woman, and I teach math. Well, the first part's true. She's a woman. Second part is not true. She would laugh if she said that. She'd laugh at herself, I think, actually. So she is a friend of mine. She would be like, she doesn't teach math. She sings English, right? So if she comes in and she says, I'm a woman and I teach math, that statement is a false statement because one of the pieces is false. So the whole statement is a false statement. Okay, you probably don't know Dr. Drake. Some of you might. Dr. Drake is a colleague of mine in the math department. Dr. Drake is Nate Drake. I think it sounds like Clark Kent. I'm pretty sure he's a superhero. It sounds like a superhero student, doesn't it? I mean, like your street name? I think it is. So Dr. Drake walks in, and he says, I'm a woman and I teach math. And you'd laugh, because visually you could look at him and go, that's not a woman, that's a guy. That's weird. Why did he just say that, right? So it is a false statement that he's a woman, but it is a true statement that he teaches math. But putting those two statements together, because one of them is still false, creates a false statement. Yeah? Yeah, that doesn't make any sense. All right, we're going to go with the last one, and you all know this particular person. This is Dr. Thomas. Okay, Dr. Thomas, president of the university, he walks in. And he says, I'm a woman and I teach math, and the whole thing sounds crazy, right? Because number one, he's not a woman. And number two, he doesn't teach math, he's the president of the university. Both statements are false. So I put them together and I make an and statement, and it still creates a statement that is false. This is altogether a false statement. Now, every time you do a truth table for an and statement, this is going to be what it looks like. I just wanted to develop it with you to show you why it works that way. Okay? So first of all, anytime you have a truth table with two statements, we'll do one with a three-statement one here in a minute, but when you do two statements, it's always going to look like this: true, true, false, false. And then they're going to alternate: true, false, true, false. These are all true, false combinations for a two statements. These are all the options. There's no other thing I could write down that would be uniquely different. And the only time that an and statement is true is on the top, when both of the individual statements are true. And that's what that definition at the top tells us. They got to both be true. Otherwise, the and statement's not true. Okay, we're going to repeat the same thing, but we're going to do it now for a disjunction, an or statement. Actually, let me copy this. You don't have to recopy yours because yours is on the same piece of paper. I'm just straight above it, but mine's not. So here's my statements again. All right, so this is an or statement. So an or statement is true when either one or both statements are true. And the truth table starts out in much the same way. I have two columns that are my individual P and Q. I have a third column that's the connective with the or, P or Q, right, my disjunction. My P column will always look, when I have two statements, as true, true, false, false. And my Q column will always go and oscillate: true, false, true, false. And we're going to remember our four characters that walked in a moment ago. I'm the first one. I walk in and I say, I'm a woman or I teach math. And you might think, why'd she use the word or? That sounds kind of weird, right? You might doubt maybe if one of those two statements were true because I said it that way. It'd be an awkward way of doing it, but it's still a true statement. One or the other is true. In fact, both items are true. So if I walk in and I say that, that's a true, albeit awkward, statement. If Dr. Rohr walks in and she says, I'm a woman or I teach math, once again, the statement would be true. One statement of it, namely that she's a woman, is a true statement. So we have a true statement when she walks in and says that. Dr. Drake walks in and he says, I'm a woman or I teach math. Again, you might be like, well, why'd you even say that, right? But it's a true statement because he does teach math. And if Dr. Thomas walks in and says, I'm a woman or I teach math, it's still false because neither of those statements are true for him. So when we look at an or statement, we get a lot of T's that come out of it, right? At the end. The only one that's not true is the one that has both the falses in there. Otherwise, I've got a true statement. Okay. One more thing, negation. So let's actually look at this one and see how a negation truth table looks. This is just a single P column because it just has P. So it says, let P represent, actually, let me put it over here, and then we'll go back to that one. So let me do negations here, and then we'll talk about the one that's there. So when we do negations, if I have a column that's P and it's true or false. So if I have the P statement is a true statement, then its negation would be, what do you think? False. It's just the opposite, right? It's supposed to be the logically opposite statement. And if my P statement is false, then its negation is that it would be true. Okay, everybody good with that? So negations just flip the T's and F's around. Okay, what's happening on the next couple is a little bit different than creating a whole truth table. This one says, let P represent a false statement and Q represents a true statement. So if you're thinking about these tables, it says P is false and Q is true. You're in this category right here. It's telling you I'm on this line of the truth table. All the rest of the truth table doesn't matter. Because they told me that P is false and Q is true. So when we're answering these questions, I don't need an entirely drawn out truth table to do them. I just need the one line that has the P and the Q that are the correct, pieces for what was being described. So this one says that I just have tilde P. So if I just have tilde P, I'm going to create what I like to call them a one-line truth table. This one's a really not exciting one. One line. So I have only the statement P, and I'm trying to do the negation of P. And it's telling me that P is what? What do the directions say? P is false here. So if P is false, then tilde P is true. And when it asks about the truth value, this statement at the end means that the answer is that it's true. That's the truth value is the last column. The next one, I have a lot more going on, right? I have two statements, P's and Q's. I also have a connective in between them, and I have a negation out in front. So let's talk about how we do this. We always start out with a column for P and a column for Q. Okay? Just like when we were working with Venn diagrams in our last chapter, we're going to do the same thing we do with, like in that section when we do with algebra, where we start on the inside of something. Okay, so we're going to start inside our parenthesis first. How are P and Q connected? With an and statement. So I need a column in my truth table that represents that. P and Q. This is what's inside my parenthesis. It just comes down as a column header. And then I need one more column header. What do you think it might be? The squiggly in front of there, the tilde. It's called a tilde. We need something with that tilde because I haven't done anything with it yet, right? And I want the tilde of what I already did in the previous column. Or you could say I want the whole thing. I want all the pieces now to fall into here. So I'm taking this P and Q from my previous column and I'm building upon it and putting a negation in front. Okay. P and Q they gave me. So even if you get stuck and can't finish something, you can always fill in a portion of a truth table. Because portions of the truth table are either given to you, like they are here, or in the cases of the ones over here, they always are the same. True, true, false, false, true, false, true, false. Right, so you can always start these. Partial credit for sure. What is P? False. What is Q? True. All right, everybody good? Points on the board, right? Absolutely. Now I need to join them with and. When is an and statement true? When they're both true. So what's this one? False. Simply because they're not both true. Last column. It's a negation of the previous column. Right, so it's true. And this right here means that my truth value is that I have a true statement. Okay, I have one more for us of this variety anyway. What do you notice about this one that's different than the ones we've just done? There are three. That's exactly right. Now, it's not asking me to create a whole giant truth table still. It's still telling me what P, Q, in this case, are, what their truth values are. We'll do a whole truth table with one at the very end. But this one's still just a truth value statement. And the reason you know is because they tell you P is true, Q and R are false. If they give you those kinds of statements, then you're looking at a one-line truth table, okay? But my one-line truth table this time needs to actually have 3 individual statements. And they just go in alphabetical order, P, Q, and then R. Okay, those are my individual statements. All right, then we start like we done the last one, right? One of the things I talked about is we start inside of parentheses first. So if I do inside of parentheses first, what will be my next column header? Q or R. Very good. Q or R. That's the inside of the parenthesis. Then what? The whole statement, because the only thing I haven't done is the connection with the P at the beginning. So I'll do P and an and statement, and then Q or R. Okay. Once again, the first three pieces are given to me. Trues and falses. What is P? True. What is Q? False. And what is R? False. And even if we're stuck, we've at least got some of the credit, right? That's helpful. All right, now we're looking at an or statement, Q and R. We need to make sure we look at the right columns. So I tend to do this. I'm going to highlight them for you. So feel free to use highlighters yourself or draw yourself arrows or something to try to keep you on track. These are the two that I'm supposed to be comparing with an or statement. When is an or statement true? When one or both are true. What can you tell me about these two statements?
Neither are true.
Neither one are true, or they're both false. So what about the or statement? It's false. Okay. Now, I need to compare the P column with the Q or B or R column. Are you with me? Right? One of the pieces said P, so I highlighted P. The other piece that I'm comparing it to or combining it with, connecting it to, is the Q or R column, so I highlighted that one. So I really only care about what falls underneath them. This is a true statement, and this is a false statement. What is it being joined with? And. When is an and statement true?
When all of them are true.
When they're both true. So what is this one? False. What if this had said an or statement on this one? It would actually be true on that, right? So my truth value for this statement is that it's false. Okay, so I didn't really justify how many numbers of rows that I have on my truth table, except to say that when we were looking at them over here, we talked about what are all my options, right? If I make this one true, what are my two options? Well, if P is true, I can either have Q true or Q false. That creates two rows. But maybe P is not true, maybe P is false. Well, that creates two rows. P is true, P is false, Q is true, P is false, Q is false. There's my 4 rows, okay? That's pretty easy to justify when you're looking at just 2 statements. If you end up with more than 2 statements, it becomes more difficult to figure out how many rows do I need on my table. So there's actually a theorem associated with that. A logical statement within component statements will have 2 to the power n rows in its truth table. We've seen that formula before. It was the same as the subset formula. Ah. There's a connection. It's not prior knowledge that's necessary to know, but there is a connection for why that's happening. So when I have 2 statements, I would have 2 squared, which is 4 rows. That's what we saw happen before. Okay? What happens if I have 3 statements? 2 to the power 3, which is 8. I'll end up with 8 rows. Now, before you go drawing 8 rows right now, I want you to look at this here. How many statements do we have? 2. Why is it 2 and not 3? Because there's not a third variable. Do you see that? It's not how many of them show up. I'm not going to count this P at the beginning and this P at the end separately just because they're in there twice. It's the same statement. It's just in there twice. Okay? So you have to make sure they're distinctly different when we're looking at them. And there are 2 distinctly different statements or letters that you're seeing. So when I create my truth table, I will only have columns for P and Q, and they will always start out the same way. True, true, false, false, and then they oscillate. True, false, true, false. Okay? Even if you can't go any further, you can always do this much and get this much credit. Now, we've got the individual statements on there, and we're going to go back up to the compound statement that's all together in the problem we were given. Starting on the inside, what do you notice? There's a negation piece. Do you guys see the negation piece? Right? We want to deal with that negation piece before we start combining things, because I'm not going to combine Q with anything. I'm going to combine the negation of Q with something, right? So I need a column representing the negation of Q. That's my next step. Now what will I do? Oops, my right symbol up there, P and tilde Q. It's everything that's in those parentheses, right? Okay, what else do I need then? The whole thing. So I've got the part that was in the parentheses I just wrote down, P and tilde Q. And then I have or P. All right, let's do them again. If you get stuck on pieces of it, still fill in the pieces you can do. The tilde Q column is almost like we get it for free. Yeah? What's the tilde Q column going to say? Opposite of what's in Q. Exactly. So for ours right now, it's going to say false, true, false, true. Once we start actually joining things together, that's when I recommend, just being really careful and, cover things up, highlight them, whatever you want. I'm going to highlight on the screen so we're all together. So it says I have the P column and I have the tilde Q column. These are my two columns I'm looking at. I'm joining them with what kind of a connective? And. All right, so we're just going to go across the first row. I have a true and I have a false. What does that give me? False. That is a false statement. The next row, I have a true and a true. That is a true statement. Row 3, I have a false and a false. False statement. And row 4, I have false, true. Also a false statement. Okay, piece by piece. Are we good with that piece? Okay. Now, I'm going to erase my yellow lines, or highlightings, and we're going to make sure we highlight the right things. The next one says that I'm going to take the piece that's in parentheses, that's the column I just created, and I'm going to take column P back at the beginning. And I'm going to do the same thing, right? I'm going to compare these two columns. What connective is going to connect these? Or. When is an or statement true? When one or the other or both is true, right? So, row 1 again. I have true and false. True. That's true because it's an or statement I'm working with. I'll try and say the word or now between them. Row 2, true or true? True. Row 3, false or false? False. And row 4, false or false? False. Notice the culmination of this problem is the table itself, whereas the culmination of these problems are the answer at the end that says true or false. Right? The problem ends a little differently. This one really just ends at the table's conclusion. And what do you notice about this one? Bam. There's the 3 variables I keep talking about, right? How many rows did we say it's going to have? 8. but they always follow a specific pattern. So let's draw them in. You're going to need 8 rows, so it's going to be a longer truth table. It has 3 columns for the P, the Q, and the R. It doesn't matter what order they're in the problem. The order in the table is always the same. P, Q, R. Okay, everybody good so far? All right, I'm going to just write in the trues and falses, and then we'll go back and talk about why it works. Sound good? Okay, that way make sure everybody's paper actually shows up correctly. The first thing we're going to do is we're going to put 4 trues in column P, and then 4 falses. Column Q, it's going to go 2 trues, 2 falses, 2 trues, 2 falses, and then column R is going to oscillate back and forth. True, false, all the way down. So true, false, true, false, true, false, and true, false. Once again, it's always going to look like this every single time. Take the points where you can get them. If you get stuck later, that's okay. At least you've got something to show that you've got the first pieces on there, okay? Okay, you can do one of 2 things next, and this is true when you have the tables like this one over here too. You can either start from the inside the parenthesis and work your way out, and sometimes that's most helpful. Or you can actually put all the negations that show up next. Sometimes it just is the same sort of thing, right? On this one here and on this one, the negation is inside the parentheses, so it's sort of an irrelevant point for me to make right now, but I gotta make it in some point. So you can put the negations or you can work with the inside. Either way on this one, we're going to do tilde Q next. Everybody good? Okay, now let me make one comment. Let's write the tilde Q in there, and then I'll talk about why this works, okay? Take a look at this truth table as it is. The top line is all trues, the bottom line is all falses, right? What we see happen in between is all the different ways that we can combine the trues and falses together for each statement. And by doing it in the same pattern every time, we don't run the risk of accidentally forgetting one or writing one twice. If we keep the same pattern, we have that established and we don't miss or duplicate anything. Okay, so I've got my column for Q. What would I do after my tilde Q, column? What, say it again? I already did we're going to write it in. The column headers first. You were trying to fill in my column. You're right, we will do the opposite of the Q column here. And you could do that now if you wanted to. I just like to fill in my column headers first. That's the order I normally go in. So what would be my next column header? The part in the parenthesis, and somebody else is telling me P and tilde Q. Yes. Okay, is that good? What's next? All of it. All of it will be next. I have R, or, P, and tilde Q. Okay, cool. So yes, just like Leah is the one that I think said to me, we're going to fill in the tilde Q column now. So this tilde Q column, again, I kind of get it for free. Yeah, you need to be careful. Don't make a mistake. But we're just going to go back to the column Q, which is over here, and I will highlight it since it isn't right next to it. And we're going to reverse this column. So this column went true, true, false, false, true, true, false, false. So what will my tilde Q column do?
False, false, true.
Mm-hmm. False, false, true, true. False, false, true, true. Okay, everybody good with that? Okay, the next column combines the tilde Q that I just created with the P column at the beginning. So it's these 2 columns. And I'm going to be doing a what kind of statement? An and statement. When is an and statement true? Both are true. So if there's any false in the line at all with those 2 statements, then it'll be a false statement. So along the top, I have true, false. What's true and false? False. The next row, I also have true and false. False. Row 3, I have true and true. That one's true. Row 4, I have true and true. True. Rows 5 through 8 are all false, and I can tell you that really quickly why. I see 4 falses in a row in column P, right? So that's enough to do it. So I'm going to just put them all in as false. You can go through piece by piece. If it helps you to see them better, that's fine too. Right? Next. The last column says I need column R. It's this one. And I need the column for P and tilde Q. That's this one. These are my columns I'm looking at. How are they joined? Or. You've got to be a little bit more careful with or statements. All right, I can't just nix them because there's a false there. When are or statements true? One or both are true. All right, so let's go line by line. First row, I have true or false.
True.
True. Second row, I have false or false.
False.
False. Third row, I have true or true.
True.
One's true. Fourth row, I have false or true. True. Fifth row, I have true or false. Sixth row, I have false or false. False. Lined paper would be helpful right now. Sorry about that. The seventh row, I have true or false. True. And the last one is false or false. False. And I do mean it. Lined paper is helpful for doing this and keeping them in order. So I'd encourage you to do that. All right, the last thing we're going to look at is the other half of the title of our section. What was the other half of the title of our section? Equivalent statements. So we're going to look at equivalent statements. In particular, they're credited to a mathematician named De Morgan. So these are De Morgan's laws. Yeah. De Morgan's laws kind of look like what we do with negatives in algebra. You have a negative and you have to distribute something through. It changes both pieces inside to negative. Y'all know what I'm talking about, right? Yeah? My kids are doing that right now in math. They're doing a lot of distribution. Negatives distributing through. But there's something that changes as well. It doesn't just change the P and the Q individually to be negated. What happens to the symbol? It switches as well. If it's an and symbol to start with, it becomes an or symbol. And if it's an or symbol to start with, it becomes an and symbol. So in a very real way, there are 3 pieces that change every time you're working with De Morgan's laws. You change, oops, I tried to do that again, one more time. You change P, you change the symbol that connects, and you change Q. All 3 get changed. So we're going to do an example with language. And we do this, I don't want to say all the time, but you do this in your everyday English where you negate things, right? You do this. So this is saying it is summer and there's no snow, and we're going to write a negation. So this is a compound statement. Let's break it apart into its pieces. What's the first statement in this compound statement? It is summer, and I'm going to underline it. What's the connective? And. I'm going to circle it. What's my second statement? There is no snow. We have to change all 3 pieces. What is the negation of it is summer? It is not summer. Don't say it's winter, right? It is not summer. Okay? Negate the first statement. Then we come to our connective. What's the negation of the and connective? Or. That's usually what people forget to do, is they forget to change the connective. So make yourself a note. Remember to change the connective. It's the most common thing for people to forget. Next statement says, there is no snow. Yeah, so this is the first time we've encountered this. If we're doing a negation of something that's already like negative, right? It's got the word no in it. All we have to do is take it off. Yeah. So we'd say, or there is snow. This would be doing a negation. These statements up here for De Morgan's laws create equivalent statements, right? You can put the negation in front. So the negation of it is summer and there is no snow is the statement it is not summer or there is snow.